Hello, good day, space explorers. Now I will discuss the origin of the solar system and identify the planets, the moons, the comets, and the asteroid. So, how was Earth formed, or how was the Earth formed? So, approximately 4.6 billion years ago, the solar system was a cloud of dust and gas known as the solar nebula. So, the gravity collapsed the material in on itself as it began to spin, so forming the sun in the center of the nebula. And also, the Earth has a central core, rocky mantle, and a solid crust. Next slide. The solar system is located within the Milky Way galaxy and about 25,000 light years to the galactic center. So the order and the arrangement of the planets and other bodies in our solar system is due to the way the solar system formed. Nearest to the sun, only rocky material would withstand the heat when the solar system was young. So for this reason, the first four planets, which is the Mercury, the Venus, the Earth, and the Mars, are the terrestrial planets. So they are small with a solid and rocky surface. Next slide. Um, the, it said that the solar nebula was formed approximately 4.6 billion years ago. So at the time of the origin of the solar system was only a cloud of dust and gas known as the solar nebula. So it is believed that our solar system was formed when a cloud of dust and gas was destroyed by an explosion of a nearby star called the supernova. Next slide. So, according to the theory of the explaining of the origin of the solar system, called the Big Bang theory, the star exploded with a bang. So, the result, or it is result in the spreading of the dust of the cloud because of the collapse. All those small pieces of matter that start out running away from each other got pulled back together by the gravitational force. Next one is gravity collapse. So the material in on itself as began to spin. So then spinning slowed down. The center of the solar nebula became hotter and denser. So which was surrounded by a dust of gas and dust that was cooled. So at the edge. So there was hydrogen ball gas whose pressure and temperature become quite huge, and the particles began to fuse and form our sun in the center of the nebula. Next one, this one. So due to the rise of the sun, the remaining particles began to clump up together into a larger collection. So the small particles grew together, bound by the gravitational force into some larger particles. So the solar wind swept away lighter elements. So the lighter elements, which is the hydrogen and the helium. So these light elements gave birth to a gas giant. So gas giant. So let me see, the gas giant, which is the helium and the hydrogen. So from the closer area, leaving only the heavy and rocky materials in order to create the terrestrial terrestrial worlds. Next one, we identify the large-scale features in the solar system and the small scale features of the solar system. So the first one, we have the large scale features of the solar system. So the large scale of the features of the solar system, which is the mass is 98.85%, and the planets are isolated in orderly intervals. The orbits are nearly circular. The orbits are in the same plane, and all planets revolve prograde. So when we say prograde, it is rotate counterclockwise. So like Mercury, Earth, Jupiter, Neptune are the or the rotate counterclockwise. While the small-scale features of the solar system, most planets rotate prograde also. So, uh, the most planets rotate prograde. The terrestrial planets have high density, thin or no atmosphere, rotate slowly, and rocky materials, and lower content of hydrogen and helium and noble gases. And next one, and the Jovian worlds have low density, thick atmosphere, and rotate rapidly, and many moons, fluid, interiors, and rich in ices. So most of the outer solar system objects are ice rich. So next slide, we have the nebular, or what comes in your mind when you say nebular. So the nebular, uh, this theory is the first scientific explanation of the origin of the solar system. So, according to this theory, the small particles of materials in the universe drew together by the force of gravity to climb up, and the galaxies, the sun, and the other planets kay nabuo na siya. So, how did the solar system form and of all these different types of objects? So currently, the best theory is the nebular theory. This states the solar system developed out of an interstellar cloud of dust and gas called a nebula. So this theory best account for the object we currently find in the solar system and the distribution of this object. So the nebular theory, they would have start with a cloud of gas and dust. So it's a simply a rotating cloud of gas and dust that pulls and contracts in the middle to form the sun, and the rest in the dust that become the planets. Next one, we have the nebular hypothesis. Nebular hypothesis. So, nebular hypothesis is self-gravity contrasts a gas cloud. It is self-gravity contracts a gas cloud, and conversation of the angular momentum pulls cloud into a dust. So, unsay mahitabo sa dust? So, the dust begin to rotate. So, mag-rotate si dust na in the central mass, which ma-form na siya o protosan. So, pag form na siya protosan, the centrifugal force balance gravitational force and a ring form. So, natin siya nag-rotate. So, the central mass would form, while pag mabalance na the gravitational force and a ring forms, mabuo na the ring forms into a planet. So, according to the nebular theory, stars from the massive and the dense cloud of molecular hydrogen, giant molecular clouds, so these clouds are gravitationally unstable. Next one, we have the Big Bang. So, what is Big Bang? So, what is Big Bang? So, in the Big Bang, this it is the universe began. It was just hot and tiny particles mixed with light and energy. So um, the universe is a very big place. It's been around for a very long time. So the tiny particles, the Big Bang, also the tiny particles group together. They form atoms. So we already know what is atom. So, then those atom group together. So, pag mag-group together na sila, over lots of time. So, dili lang siya kuan, over lots of time. So, atom came together from the star and the galaxy. So, pag the first star create bigger atom and group of atom that lead to more star being born at the same time, the galaxy were crashing and grouping together. So kuan na ni atom, so a new star were being born and dying. So Then ma-form na sila um, asteroids, comets, planets, and the black holes will be formed or form. And then the Big Bang, who came up with the Big Bang theory in 1921, it was George Lemaitre. So the matter from all the universe came from the very hot central point. Sooner or later, the central point began to cool, and 15 billion years ago, so those atoms were drawn together gra- uh, by the gravity. So this region exploded and matter was thrown outward. So the Big Bang should have created equal amounts of matter and the antimatter in the early universe. But today, everything we see from the smallest life forms on the Earth to the largest stellar object is made almost entirely of matter. So next one, the antimatter. So the Big Bang was thought to produce two main types of particle, which is the matter and the antimatter. So the matter and the antimatter is equal quantities, cancel each other out. So the universe is made up of after 5,000 years. So particles from the atoms and molecules start to gather together and from the galaxy and the sun. So when we say the antimatter particles share the same mass as their matter counterparts, so but qualities such as electric charge are opposite. So the positively charged position. So for example, no. So if the antiparticle or the antimatter is the negatively charged electron, the matter and the antimatter particles are always produced as pair, and if they come in the contact, leaving behind pure energy. So, during the first fraction of a second of the Big Bang, the hot and dense universe was buzzing with particle and antiparticle pairs, and it seems the universe should contain nothing but leftover energy. Next one, we have the Hubble constant. So it's the unit of the measurement used to describe the expansion of the universe. The cosmos has begun getting bigger since the Big Bang kickstart to grow about 13.82 billion years ago. So the universe, in fact, is getting bigger, faster in its acceleration as it gets bigger. So, what's interesting about the expansion is not only the rate but also the implications, so according to NASA. So, if the expansion begin to slow down, that implies that there is something in the universe that is making the growth slow down. So perhaps the dark matter, which can be sensed with conventional instruments, so if the growth gets faster through it's possible the dark energy is pushing the expansion faster. Also, the Hubble's constant, also known as Hubble-Lemaître law, so it is the observation in physical cosmology that galaxies are moving away from the Earth at speed proportionally to their distance. So, in other words, the farther they are faster, they are moving away from the Earth. So, the velocity of the galaxy has been determined by the redshift. So, a shift of a light they were emit towards the red end of the visible light. So, if which establish that if you know the period of timing of a Cepheid star pulse, you can determine its intrinsic brightness. So, by comparing the intrinsic brightness to observed brightness, you can also determine the star distance. So, because it dims as it's moved farther away. So, the distance measurement used by the Spitzer telescope, so to measure the expansion rate of the universe more precisely. Next one, we have the protoplanet. So what is protoplanet? So, according to the protoplanet hypothesis, the planets that form farther from the forming star tend to be larger because the heat from the sun evaporates the gases closer to it, reducing the mass of the forming bodies. So, the greater mass allows the larger planets to accumulate mass faster due to their greater gravitational pull. So the rocky planets towards the interior of the solar system have much less hydrogen and other gases in their composition. So this, the hypothetical whirling gaseous mass within the giant gas cloud of gas and dust that will or that rotates around a sun, and it's believed to give base to the planet. Next one, we have the protoplanet hypothesis. So the center of the compressed gas cloud become hot, and eventually the core become the sun. So rotation axis. So next, the hydrogen fusion. So 10% of the glass form a dust surrounding the sun. So surrounding the sense of fraction within the dust cause all the mass to collect into edges. So these edges were compact and became planets and moons. So as I've what said, the protoplanet, so it is a smaller than a dwarf planet. So pag mag-collide na siya, collide asteroids, so become larger. So when it become a larger, they will become a dwarf planets, or they become a planet. Next, we have the steady state theory. So, steady steady state. So, we all know about the Big Bang theory of how the universe came into existence. So, the steady state universe theory is put forward is an alternative to the Big Bang theory. So, the steady state theory states the universe is always expanding, but it uh, maintains the same density. So, we know that the state of matter depends on how dense its particles are. So, those if the density of an object remain the same while the size continues to increase, we can say that the object is an constant or steady state. So also the steady state universe has no beginning or end and any from any point. Next, we have the platesimal theory. So the platesimal theory was formed from the material of the solar nebula. So the solar nebula is thought to have been dust-shaped cloud of gas and dust that remained after the formation of the sun. And also it proposed that a star actually get close and collide with the sun. So as a result of accretion, the small sized dust grain begin to clump together as they collide. So magkumpul-kumpul na siya, mag-collide na sila. So ma-form na siya into a larger bodies of platesimal. So when the platesimal reach a size about 1 kilometer, they began to attract other smaller bodies. So ma-attract sila na pod sa into a smaller body, so due to their gravity. So eventually, the platesimal got large enough to attract bigger bodies that turn into or form into protoplanets and planets. So many collision between the platesimal result in breaking up in the bodies into smaller and smaller bodies. Next one, we have a accretion theory. So a pile of space, dust, and rock chunk pushed together into our planet. So another pile pushed itself into our moon. So then the moon got close enough and began encircling the Earth. So is the theory that particles that form after the Big Bang slow clustered together to form the asteroid, planets, and even stars. So this happen kung ang cloud of gaseous material and dust mag-compress to form an accretion dust. So which serve also as a catalyst for the formation of the sun and the galaxy. So, what did accretion cause? So, ang accretion involved the addition of the material to a tectonic plate. So, when the two tectonic plate collide, one of the plates may slide under the other, kay matawag to siya or process to siya known as a subduction. So, the plate which is being subduct is floating in the asthenosphere and push against on the other, so other riding plate. Next, we have the planetary collision theory. So the Earth collides with another planet, and that collision caused an explosion that threw rocks through rocks, the rocks became our moon and start to orbit us. So this resulting explosion through of rocks which form are orbiting the moon. So for decades, most astronomers have agreed that the moon is the result of the giant collision between the Earth and the Mars-sized object. So the impactor, but not everyone can agree on the exact mechanics of that collision. So right now, the theory suggests that the impact was relatively low energy, leaving the Earth mostly intact but causing the impactor to melt into magma. So, next one, we have the stellar collision theory. So it started in the year in 1764 when a star cluster known as the Messier 30 was discovered by an astronomer called Charles Messier. So the coming together of two or more astrological bodies which merge and form into a larger unit through the force of gravity. Our planets, moon, and suns spun off from the collision between the stars. So it is coming together of two or more astrological bodies, so which merge and form into a larger unit. So through the force of gravity, as the same applies, stellar collision means the collision of numerous star. So ngano ni so when the two star cross paths and get pulled into a newly formed binary system as their orbits decay, mag-merge na sila into supernova explosion. And usually one of the two will survive to coalesce into the new single star. So that's the end of my reporting. Thank you so much for listening.